Hello and welcome back to Mr. Farina's algebra class. Today we're going to incorporate a new factoring method called the AC method. Now so far, just to review real quick, in this class we have factored the GCF, we have factored by grouping, and we have factored quadratic trinomials, alright, when A is equal to 1. So we had ax squared plus bx plus c. That's a quadratic trinomial where this a was equal to 1. Well, let's look at these as a quick review. Before, if we gave you the quadratic trinomial x squared plus 5x plus, say, 6, this was an easy factoring problem because all we did was find the numbers that multiply to give you 6 and add up to give you 5. And you would find those factors. Okay, 3 times 2 is 6, 3 plus 2 is 5. Then you would go ahead and write it as a product of two binomials, x plus 3, x plus 2. And this would be the factored form of x squared plus 5x plus 6. Well, what happens if we changed it up and gave you, the quadratic trinomial, 10r squared minus 2r minus 8? Now what happens is basically it's a little bit different, because now not only do we have to go ahead and find the numbers that multiply to give us 10r squared. That could be anywhere from 5r, 2r, it could be 10r and 1r, but it's going to change the rules of what we get when we add the terms together in the middle. Therefore, we have to look for an easier method to use in order to accomplish factoring. There are several methods out there, ranging from guess and check. One that I've seen done is called borrow, payback, reduce. The one we like to use is called the AC method. Now, the key here is understanding that we only use this method if there is a number other than 1 or 0 in front of the x squared term, or in this case, r squared term. So, AC method, let's take a look. When do we use the AC method? Well, it's used when factoring the quadratic trinomial ax squared plus bx plus c when a is not equal to 1. Now the steps are real simple, and the thing you have to understand is once you do one problem, all of the other problems are identical. It's just being able to work with the numbers. The first step is to put the polynomial in standard form. So you want it in descending order by degree. We'll learn later that the first step truly is factor out the greatest common factor, but in this case we're just going to start simple. The second step is to find the factors of AC. So what we're actually going to do is take the coefficient of x squared and this constant, we're going to multiply them together, and now we have to find the numbers that multiply to give us that product of A and C and add up to give us that B term. Now, just to make it easy, let's call those factors D times F. So we're going to say D times F is equal to AC and D plus F is equal to B. This is going to help us understand the third step. Our next step is going to be to break B up into a sum or difference using the factors from step 2. So once we do this, we're going to rewrite the problem as ax squared plus dx plus fx plus rc. So basically, we took these and we accompanied them with an x to help us define that middle term. Well, yesterday we learned how to factor by grouping. Then the final step here is basically just to go ahead and factor by grouping. Okay, so pretty much every step in this method you guys should already be aware of. So let's take a look at a couple of examples here. So in this first example, if I look at it, this 5 in front of the w squared tells me I have to use the AC method. So if we multiply A and C together, A is 5, C is 1. That tells us we have to find the numbers that multiply to give us 5 and then add up to give us. So multiply to give us 5 and add up to give us that middle term, negative 6. That's a negative 6. Let me erase that and go negative 6. So what numbers off the top of your head multiply to give you 5 and add up to negative 6? Negative 5 times negative 1, negative 1 gives you 5, and negative 5 plus negative 1 gives you negative 6. So, since these are the factors that make both of these happy, we're basically going to bring down the 5w squared. We're going to basically bring down the 1, and now we're going to rewrite this middle term using the negative 5 and the negative 1. So we're going to go minus 5w minus 1w, and that's plus the 1. Well, the last step is to now factor out the greatest common factor, or factor by grouping, I'm sorry. So, greatest common factor between these two terms, well, 5 and 5, greatest common factor 5. You have w squared and w, you can pull out a w. When you divide each of these by 5w, we end up with w minus 1. From the next one, right here, if this leading coefficient is negative, we have to pull out the negative. The common factor between 1 and 1 is 1. And if we divide both of these by negative 1, we end up with positive w minus 1. Always check to make sure your binomial factors in grouping match up. Do they? Yes. So we pull out that common factor, w minus 1. And if I were to divide this term by w minus 1, those cancel out. I'm left with 5w. And if I divide this by w minus 1, those cancel. I'm left with minus 1. And this is a factored form of 5w squared minus 6w plus 1. If I wanted to check my answer, I could basically go ahead and redistribute. W times 5w, 5w squared. W times 1, negative w. Negative 1 times 5w, negative 5w. Negative 1 times negative 1 is plus 1. And you end up with 5w squared minus 6w plus 1. And is that the polynomial we started with? It sure is. So this is our correct answer. So let's take a look at the next problem. So again, the steps are going to be the same. If I take a and c and I multiply them together, negative 14 times 3 tells me I need to find the numbers that multiply to give me negative 42 and add up to give me this middle term, which is 1. Now, you really have to know your multiplication tables here and be able to add in your head very quick in order for this to work efficiently. So what numbers multiply to give me negative 42 and add up to 1? Well, I know my bigger number has to be positive, because when I add them, I'm going to have to get a positive. So 7 times negative 6, that'll give me negative 42. 7 plus negative 6 will give me 1. So these are the numbers I will be using to rewrite this middle term. So as we did before, we bring down the first term, 3z squared. Now we are going to rewrite that middle number using these. We're going to go plus 7z minus 6z, and then we're going to bring down the minus 14. Well, once we do this, the last step is easy. Factor by grouping. So what's the common factor between 3z squared and 7z? Well, 3 and 7, no common factor, but they both have a z, so we'll pull out the z. What do we have left when we divide? Well, we have 3z plus, the z's cancel out here, 7. And again, leading coefficient negative. Make sure you factor out that negative. So negative, between 6 and 14, the common factor is 2. You cannot factor out a z because they both do not have a z. So I'm going to factor out the negative 2. And negative 6z divided by negative 2 is positive 3z. Negative 14 divided by negative 2 is positive 7. Notice, our binomial factors are the same, so I know I did everything right. So I factor out the common binomial factor, and when I divide both terms by that binomial factor, these cancel out. What am I left with here? Z minus, what am I left with here? 2. And you'll notice, if you multiply these two binomials together, you would get the polynomial you started with. This is pretty much the lesson for tomorrow. So make sure you do the practice problems to get full credit for your homework. Have a good night.